Good afternoon. My name is Mark Tabladillo, and this presentation today is Enterprise Data Mining with Microsoft SQL Server. And I am a consultant. I blog on the topic of data mining, and there are some websites that I'm going to be recommending later. One of them is my own blog. Someone had asked me just before the presentation, is there anything new with Denali? I did talk about Vertipack, for example, on my blog. I talk about many things and how the data mining technology will mix and match with other parts of the Microsoft SQL platform. But today we're going to focus specifically on analysis services. Just a little of my background. Again, I am a consultant, and I have worked with different countries and clients here in the U.S., telecommunications, media companies, healthcare, insurance, government, so a wide variety of companies using this technology. And another thing, also I teach at university. I'm a part-time instructor. Well, let me tell you about my educational background a little bit. The Bruins, what school's that? Yes, and Yellow Jackets? Okay, that's my graduate school, and so I'm an Atlanta native, and this is my town. So glad to have you all here in my town. Lived here for 20 years and went to graduate school there, but I'm teaching now part-time at University of Phoenix in the graduate program, mentoring dissertation research online. So that's a new thing I'm doing, working with students here in the United States and around the world. So, and I've taught statistics, both University of Phoenix and Georgia Tech. Now, today's presentation is not about that focus. Of course, this is TechEd, and we have many people here who are developers, architects. Maybe you're an executive, a manager considering technology. And so that's the audience here today. Let's focus on the three words of the title, the word enterprise. And the word enterprise means different things. And if you think of a graphic or an image, you might think of that science fiction series. That was the name of the ship, USS Enterprise, and there's also a U.S. battleship with the same name. There's a space shuttle with the same name. But in my presentation here, I have three specific pictures of ships. I'm going to ask you to choose some of these ships. This first ship is a cargo ship for an Enterprise. And the second ship is kind of a sailing, clipping ship. And the third ship there is a cruise ship. Third ship there is a cruise ship. Okay, interactive activity. All right, now don't spend too much time thinking about this. There's three ships on the screen. They all represent Enterprise. And what I'm going to ask you to do is pick a ship that most resonates with your current experience. Your current experience. Just pick one. All right. So, and then show of hands. So, number one ship is on the left, the cargo ship. How many people resonate with that image? Cargo ship. Cargo ship. Okay. Second ship, the clipper sailing ship. Okay. And then the last ship, the cruise ship. Okay. Now, I didn't write it down on the paper, but actually those results match the results I had when I spoke at SQL Rally last Friday in Orlando. It was first one that the people picked was the clipper sailing ship, and then the second one was the cruise ship. So that type of exercise, to be able to predict what people would do based on past experience, is the type of thing that data mining provides. It provides insight into information that does not yet exist, that you could not drill down in any cube or any data warehouse and still have a probabilistic understanding of what might happen in the future. Second term here is data mining. And as I use the phrase data mining, I use it to inform actionable decisions. And in fact, I feel that's the goal of not just data mining, but business intelligence, period. Business intelligence or BI. Another term you might hear is machine learning. And increasingly, for people who go to graduate school or getting a computer science degree, seems like everyone these days is having to take a class in machine learning or in algorithms. And the goal there is slightly different. It's about determining the best performing algorithm under certain conditions. I had a recent anecdote. There was a guy who just got a mechanical engineering degree this year from Georgia Tech, master's degree. And he was asking me, what would he do? And I said, well, I work with data mining. And he says, well, what's that? Never heard of it. So I started explaining that. He says, oh yeah, he said, I think I know what you're talking about. I said, you know, I work in robotics, and we deal with classifiers, and we wrote some search algorithms for that. But he did not know the phrase data mining because he's coming out of the engineering school. It's a phrase that's used more in the business community, and if somebody who's just come through school and maybe had only a science or an engineering education may not have heard of that phrase. In industry, the phrase data mining has to do with using all the machine learning algorithms, but using them all together. And it's an approach I recommend, you know, not necessarily just competing them to look for the best one, but using all of them, maybe using several types of classifiers to determine an outcome. And the third phrase from the title, SQL Server 2008 R2. Okay, so here is a diagram that is small to read. It's not intended to be read, but you can see that there's boxes on the screen, and there's pieces inside the screen with text in them. This is the server physical architecture for analysis services. And then the second diagram here, this is the server logical architecture for analysis services. And it's different, you know, you go back to the physical architecture, so that's the first screen, and the logical architecture. Now, if you have to leave early today, or if you want some quick value here from this presentation, here's your first insight on this physical versus logical. Now, the reason this one's logical and the other one is physical is because the physical one is not logical. All right, that's the first takeaway here. So they call it physical because it's not logical. And then the logical one, well, they call it logical because it's not physical, it's not actual. And that's not just true for analysis services, it's true across all the product models when people explain it. So here's the outline, and I'm going to talk about today the Contoso Retail database and some fundamentals of data mining. I'm going to do an enterprise-level data mining demo for SQL Server. Now, it's a lot of words, but it's just focused on the word enterprise. It's enterprise, it's data mining, and it's SQL Server. And then at the end, I will have some next steps, some follow-up resources. So the first phrase here is, what is Contoso Retail? It's a demonstration data set for the SQL Server database engine. Some of you may have heard of AdventureWorks. Well, Contoso Retail builds on that type of example. It's already built out. It's something you can download. There are two parts. One's for the relational engine. The second part is an analysis services database. I have a link on there in the slides. You can go download it yourself. And this framework here, this is the framework that I am using to explain this specific presentation, but also data mining in general. And this framework is mine, so you're not going to read it in books online or anything probably that you've read on data mining or on this topic, period. In education, you have this framework of reading, writing, and arithmetic. And they often call it the 3 R's, and the reason if English might not be your first language is if you drop off some letters, you can get to reading, writing, and arithmetic as I have on the screen. But then I spell out the words reading, writing, and arithmetic. Focus of today's presentation is not on the arithmetic. The focus is on the reading and the writing. And why is that? Because my argument today is that Server does a lot of the arithmetic for you. Whether you choose one algorithm or another, whether you set parameters, a lot of that is already done by computers or servers, and that's what the main task of them is for. And it also often requires advanced mathematics to understand at least data mining. But reading and writing, my argument is that's where a solution that's maybe arithmetic could become an enterprise solution. And just as an example, when I was in graduate school, one of the tasks I had in one of my classes was to do a time series analysis using only Excel. And it was a doable project. They showed us how to do it, how to accomplish a task. And that turns out, that wasn't just my experience. I had another friend who recently got an MBA from University of Pennsylvania. And in his coursework, he had the same type of a task. He had to do a time series analysis using Excel. So, as far as arithmetic, it could be a desktop solution. A lot of the mathematics that are behind data mining could be replicated or programmed in a product like Excel. But as far as the reading and the writing, now that's when it becomes tricky. It becomes tricky in an enterprise. You remember the earlier vision casting I had of ships, that ship theme, cargo ship or sailing ship. To be able to have many people reading or many people writing at the same time or on the same database, that's what makes a task more of an enterprise type task. All right, so, but one more thing on the reading and the writing. One of my Microsoft friends is Ed Wilson. He is the scripting guy. He's the man that posts the scripting guy's website for PowerShell. And he mentioned that the most frequented post that people hit on the PowerShell website has to do with reading and writing text files. That's the single most common topic that people are interested in. And he said, although he's written a lot more advanced things and there's other topics, it is a very common topic that people want to put in production environments. So what enterprise tools are we talking about today for supporting data mining? The ones that I will be showing here are SQL Server Management Studio, which is often abbreviated SSMS. The second is called Business Intelligence Development Studio, which is BIDS. And within there is SQL Server Integration Services. And then the last tool is PowerShell, which is version 2. Of this list, the first two tools come with SQL Server. So if you obtain SQL Server, you're getting the Management Studio and BIDS. And by the way, you're also getting the data mining product. You get analysis services and you get the data mining product. We're talking about enterprise, and that's also the edition I recommend to get of SQL Server, because there are slight differences between enterprise and standard edition for data mining. And so those first tools come with SQL Server. The last tool is available from the Microsoft website. It's often now installed on newer systems. You know, I just upgraded a lot of my machines to Windows 7 64-bit. It already came with PowerShell. But even if you have an older Windows operating system, you can often get a PowerShell downloaded for that. Okay, so here's our demo. Let's flip over to the demo. We're starting with Management Studio. We're going to do 3 interfaces. And I will mention here at the front that the data mining technology in SQL Server, it is not an application, it's a service. That might vary from other data mining products that you might see for sale or many other open source products that might run on your desktop. Those are applications. This is a service. So a service, therefore, has to have an interface. And the interfaces I'm showing today are these 3 faces for data mining. On the left side here, I have the Contosa Retail Analysis Services Database. That's what it's called, Analysis Services Database. Or they often will abbreviate it AS Database. Right now it's expanding. So you can see there on the left. Now this is a completely built-out example. So if you download it, you'll see that there's a data source, one data source view. There's 2 cubes in this demonstration database, and then there's also several dimensions in the database as well. And then right now it's expanding the interface. Okay, now we're live. All right, now I'm going to explain a concept about structures and models. So I'm going to zoom in on the screen here. This is a logical description, right? This is a logical description. There's physical and logical. So the structure, the first structure on the list here is called basket analysis, and the second one's called customer classification. The third is customer promotion, and the fourth one is product forecast. And let me just close that for a second so that you can see that more clearly. Okay, this is the key thing to understand before we get into it. So the structure is like a container. Structure is a container. The models live inside the structure. In this case, they put one model inside of each of these 4 mining structures. And we're going to look at them in a second. One question that I had, and I looked for this answer in books online, is how many models could fit in a mining structure? Does anyone know an answer or can guess? No? Sorry? 6? As many as dimensions? Okay. There's 2 limits, and I put this on my blog since it's not in the books online. I got 2 different answers. I got a theoretical answer and a practical answer. The theoretical answer is 2 to the 31. The practical answer is 64K, and I think the practical answer has to do something with addressing or memory, something like that. But anyway, it's a very large number. It is beyond the number that I would recommend for practical use. If you had 64,000, if you make a mining structure with 64K models, I will come to your work and punch you out. Okay? So that's how bad it is. So don't do that. All right? You're asking for trouble. So pragmatically, it's not like, the same thing with Excel. If you make an Excel workbook and fill it with worksheets, don't do that. Don't do it to yourself. So there's often ways to achieve goals without having to go that far. And in fact, one of the goals of statistical techniques like data mining is a word called parsimony. You're trying to make things as simple as possible. You take this much data, see what I do with my hands, you take this much data in your data warehouse or your cube, and what you want to do is compress the understanding in a very smaller amount or smaller section so that people can wrap their minds around it and be able to make decisions. So you take this much, and what you're trying to do is parsimony. And we do this all the time. We make guesses. One of the things that I've used as an example, if you're going to give somebody a gift or a present, and it's a surprise, how do you know what it is they like? How do you know in advance? You don't actually know. You know maybe probabilistically that they will like it. And so it's a type of a mental activity that does happen a lot. And I have found in doing these technical presentations, I have to often give examples like that for people to think about what is and is not in a database. If I click Browse, and that's what I did with the model here, this first model is a forecasting model. This one is probably the most familiar to anyone who's not seen data mining before. Time series, sometimes people do not consider time series a machine learning algorithm. Sometimes they do. For pragmatic purposes, it's in the Microsoft data mining stack, so it's something that you do get. And just here on the interface, these are different series, and it'll take into account seasonal variation that might be in the model. As you see on the right side, I've turned on the deviation bars or graphs, and toward the top of the graph on the screen, it shows that the deviation bars get wider as you go further away from reality and into imaginary land. And on the bottom one there is some deviation bars, but they don't show as much of a variance across time because it's a fairly flat prediction. So that's just the way it turned out on that model. Time series is a very common task, and people might want to do that. So right now what we're doing, remember, we're doing reading, writing, and arithmetic. The arithmetic has already been done. Someone processed this model. Someone chose. In the mining structure, what you're doing is you're choosing the variables or the columns that might go into the models. And then the models themselves are maybe the entire set or just a subset of those variables. And then you're also choosing the specific algorithm with its parameters. So those combinations of algorithm plus variables is what makes the mining model. Now, previous to opening this model, someone had already trained it. And they trained it using the data source or the data source view, which is in this database. So there's Contosa Retail. Right now we're in Analysis Services. It was trained from the relational engine. There's a Contosa Retail data warehouse, and that's where the data came from. There's 2 words you'll see. If I right-click here, that word process, that's something that we would have to do if there were no data showing on the screen. The word process and the word train are essentially the same. You'll see both words in the documentation, they mean the same thing. The word process is used also in processing cubes, but it's also used in processing models. So the word process there. So again, we're just reading right now. And this is a different view of that product forecast. And it gives kind of a decision tree type viewer. It's called time series viewer. And it's just a different way of looking at the graph. I could just looking at the screen right now, I could copy this chart right now to the clipboard right there from Management Studio and just manipulating it there, put it into some other type of document. So again, this is one of the faces or interfaces of the data mining service. That's number one. Let's look at two. Two is going to be decision tree. And the goal, a decision tree is what's called a supervised algorithm. A supervised algorithm has to have a target or a goal. In this case, the goal is on the right. I'm going to zoom in on that. The goal is determining people who did or did not have a seasonal discount. So who did and who did not have a seasonal discount. And I'm going to read the graph. Let's just read it and see what it says. We're reading, right? We're reading. The first variable here is number of children of home not equal to 0, and that there's a blue bar underneath, meaning that nobody there got a discount. Everyone who got a discount had a number of children of home equal to 0. And then as we go across, let me see that that's correct. A seasonal discount, excuse me, I said it the opposite. Seasonal discount, everyone who had number of children of home not 0 got a discount. And then this one was split. And it has there in the box how many did not get a discount and how many did get a discount. How many did not, how many did. And then the third variable there is either they're married or they're single. All right. There's a dependency network here, and that's what shows on the second pane. It's a different type of view on numeric data. Microsoft provides several viewers on the data. As I've worked in my consulting practice, sometimes I'm working with a team right now of consulting with some developers, and they're writing in Silverlight, they're writing in ASP.NET, and they're just reading the values directly from the database, and they use ADOMD.NET, and then they're putting it on their web application. So you can use these viewers, but you don't have to. And as I've talked with some vendors, and there was a vendor that stopped by earlier and as in the DBI section on the expo floor who was asking about visualizations. I feel that there's a big opportunity now for people who want to make visualizations in Silverlight or in some other technology. So these are some basic viewers, but they could be improved on or changed or altered. So that's decision tree. And let's just quickly go through the next two here. Clustering. Let's give you a sense what that looks like. This is clustering. So clustering is the idea of clustering is a unsupervised algorithm, and it takes all the variables that you present to the data mining algorithm, and it could be a large amount, and it's trying to figure out the groups that are most distinct from one another. If you took all those variables and you try to making distinct groups. On the left side, there's a slider that shows strength of connection, and you can kind of see that on the screen here. Not every line on that diagram has the same level of shading. So, you know, maybe if I slide this up here, maybe that represents all your friends on a social network. Maybe it's on a Facebook. Okay, so this represents all your friends, and as you slide it down, it represents friends that are, you know, more connected to you than others. And wouldn't it be cool for some of you developers in the audience to come up with some sort of Facebook app that would let me do that, that would let me choose certain characteristics inside Facebook and say, all right, based on those characteristics, I want to slide this up and down and find the friends that have the most similarity of my current network, you know, that are there. I know it recommends to me friends, you know, if you have 45 friends in common, here's another friend that you might want. But what if I applied the weights? What if I had the ability to say, you know, certain characteristics are more important than others? The second screen here, this shows the different clusters and characteristics of those clusters. If you look on the left side, it took variables that we commonly know, age or education or gender, and then shows differences among the clusters. In this particular example, gender doesn't show much of a difference across the clusters, but education does. And I'll show you this one box that you might be able to see. It's purple. Okay, that's under cluster 8, and that purple represents graduate degree. So everyone in that cluster 8, which is 979 is the sample size there, has a graduate degree. And again, the goal was to try to make these groups as different as possible based on the variables presented to it. This is a short list. You could use a much longer list with data mining. It goes way beyond that. Cluster characteristics, again, another visualizer showing you what different clusters look like. The cluster I like to pick on in this example is cluster 2. Age is greater than or equal to 62. Number of children at home, 0. Number of cars owned, 2. House owner flag, 1. Marital status, M, standing for married. Gender, either M or F. Represents a couple, maybe retired, with 2 cars, owning a house, married, empty nester. And as you read down the pane, maybe there begin to be characteristics that are contradictory, that they could be true at the same time. But that's the general idea of what clustering does. Clustering puts similar things together. The last example here is an association analysis, also known as market basket analysis. And it's the same type of thing that you may see on websites where they mention you may have interest in one product and they're recommending some other products to you. It's the type of activity that marketers love because it's targeted marketing. If you're interested in this, maybe you're interested in that. And in this case, let's go to the item sets here. Now, how many of you have seen the VentureWorks data before? VentureWorks data before? Okay, you know it's all built on cycling. But how many of you knew that VentureWorks is now making 26-inch 720p LCD HD TV now? They're in consumer electronics, according to Contoso Retail. So VentureWorks is not only making bicycles, they're now in consumer electronics. One thing that will be true in this analysis, you notice that the colors are in the analysis. So in the second row there, it has an VentureWorks HD TV, and the color is silver. And then on the second line, it has the same product, and then also on the right side is a DVD, which colors black, and then the next line is the color's gray. You may or may not, depending on the business question, be interested that people are buying a particular color of an item. If you were not interested in the particular color, what you would do during the ETL process is you would recode a new column or a new attribute so that all the products with that, whatever color that is, you would drop the color before presenting it to data mining. And that would be how you would handle that. And the reason is because then when you look at the dependency network, it shows a relational diagram, and you see on the screen there one of the telephoto conversion lenses there, that color is silver. Well, it does not include any of the other colors. Maybe that's important, maybe that's not. Maybe it's important that you know if it is silver, but you could do it 2 different ways. Again, I will mention that like before, you can still copy or paste the information from this diagram. All right, so that gives you some visuals. I'm going to go through some code now. I love code. So this code, what I'm showing right now is called DMX. It's called Data Mining Extensions. On the right side, what I have open is something called Template Explorer. You open it using the View menu option. You get Template Explorer. There's also some examples for SQL Server. But on the right side, you have some code samples for DMX, MDX, and XMLA. Now, of the 3 that are on the Analysis Services panel, the DMX examples are pretty well built out. They have model management, model content, prediction queries, and structure content. All right, so let's look at some of these queries. I'm going to execute it against Contoso Retail just to look at the content of that sales order model, and that was the first one, the association analysis. So let's go down. First of all, there's a lot of rows. Okay, a lot of rows. And on the right here, you can see what some of the node captions are for that row. And I'm showing you about reading this from the comment I made earlier. Some people like the visualizers, but some people would just like to get their hands on the original raw data, and here it is. Now, this query did not just return a flattened table. As you see on the right here, the node distribution has a pop-out box. So it's kind of like a nested table structure. And a lot of the data mining models have that same type of nested structure. Again, we're just reading. We're not talking about creating or how do you make this. We're just reading what was in here. If you ran a query against this table, you could get this information. In my query statement, I did select all, so I'm selecting all the available possible columns for the content. But you could name the column that you want and just get that column. All right, that's the first one. That's for an association analysis. Second one for clustering. In this case, there's a total of 10 clusters, and then they have a 0. So the 0 column represents the all, and then the individual nodes there have descriptions that kind of look descriptive of what you would expect, would explain what was in those different clusters. And again, something about the node distribution. So I'll open that a little bit more. And you see here when I slide to the right, there's probabilities in here and variances. There's some probability values that live in the model according to total children and other levels of variables. For many of the models, they do require categorical variables. Data mining will automatically make categories for you. If you don't like the categories that it does make automatically, you can make categories before it's presented. So for example, sales amounts, it might break it at values that are not, multiples of 100 or something like that. In this case, I can see, for example, this consumption variable. You can see how it broke the data mining model, broke it at very odd places. I can see when there's 51.205.382.438.912. Well, that one was automatically done. That's what I know just from reading it. So somebody could go back and they could redo that if you wanted to have nicer categories. But the good thing is it does make them. So even if it's not pre-prepared for a categorical variable presented with a straight continuous variable, would still work. Third one here, forecasting a decision tree. Same type of thing, and part of what comes along with that is the captions. So notice the captions are already there. So let's say if you were reading this into something else, you could still have those captions, nice captions that come with it. You have your probabilities, and then again, some type of node distribution. And I will mention something here that I have asked sometimes audiences to explain. So there's a missing, a node discount, and a seasonal discount. And in this case, the missing had a support of 0. Just by default, analysis services will make a missing category, and the reason being that if somebody were to run a future query and have a value that was not in the original data, that you still could get a result. So in other words, in this case, if I ran a query in the future and a promotion type did not equal either no discount or seasonal discount, it would still return a value. That's a feature you should check if other data mining products, if they can do something like that. The last one here is a forecasting. And on the right side here, again, a node distribution. So again, it's kind of a nested structure. Model attributes, there's some call procedures that go along with data mining. They are documented in books online, so you can see what the call procedures will do. In this case, I'm doing the call procedure against the clustering model, and it's showing me the attributes that were presented to the model on the bottom. So I can see what was originally presented to that model. Decision tree. There's an example for that. It shows what went into that. And then the last one here is the online sales orders. Now this one's going to be long. Why is it long? Because there's a lot of products. That's why it's long. And again, notice there that they did it by color. So the first row says azure, then black, green, gray, orange, pink, different colors of the same product. If you didn't want to do it that way, or if you needed to answer a different type of business question, you could pre-categorize those items. In this case, 1827 attributes went into the entire model. That's what makes this specific one the most complex in terms of the resulting table. Continuous column values. It will also query the model and look for values for the min, the mean, and the max. And this case, I'm looking at the forecasting model, and I'm asking what was the min, the mean, and the max of sales in the forecasting model, reading. So there's some examples there of continuous column and then discrete column. Select distinct education from cluster customer. Okay. Bachelor's, graduate degree, high school. So that's what went into that model. Now, let me just stop right there. And I'm going to make a point here. This was for the clustering model. Now you look on the screen, again, you have the structure, and inside the structure is the model. If I were to take that model and train it against another data source that had different types of levels of education, it would still work. Okay? All it needs is to know that there's a field called education out there. It doesn't matter what the contents are, it would just train it against education. So let's say I trained it again, and I did some sort of view, and the view had only, the first level here, it says bachelor's, and that was it. So the trained model, that's all it would have. When I did the query, it would just say bachelor's. That's it. That's all that went into the model. So it does depend on what the data source is for what values will come out of it. The model itself is built only on that column name, education, but the training is what determines what the levels are on the bottom. PMML is a topic I talked about on my blog, and I put a note inside this demo of where that will be. And by the way, I am going to upload this to my website, marktab.net. So if you want to get this demo code, it will be there. The PMML is a specification for saving a data mining model in XML format. Oh wait, I shouldn't put it in here. I should put it in XML. I'm going to paste it into XML Notepad, which is a free giveaway. And so it comes out as an XML structure, and it's a type of way to share basic model information across systems. Now, is it sharing the trained information? No, it's just sharing the structure of the model, not the trained part. So there's no data in here. It's just the model specification. So that's what that is. So let's go on to the next example. Renaming model. Now, one thing I noticed is there's a spelling mistake. So the spelling mistake is they misspelled the word forecast, F-O-R-C-A-S-T. And this code shows you how to rename models to a different name. Okay, so that's the type of thing you can do. Rename models. You can rename structures. And now what I'm going to do is talk about exporting. So we have this mining structure here. Let's focus on this code, export mining structure. And what I did is I named 4 mining structures, an output file, and I put the keywords there with dependencies. And the reason I put with dependencies is because the mining structures and models are connected to the data source. It needs the data source connection to retrain that model. So if I wanted to move these models and structures out of this analysis service database and put into another one, I can't just copy the mining structure and the mining model. I need also those connections. If you wanted to do that some other way, it would be kind of complicated. This is actually the most straightforward way to do it, is to use a command like this. So if we do this command, and it takes about 10 seconds, what it does is it makes a file that will have the trained model information stored inside a file. So let's see that. So I just made the one from SQL Server Management Studio. These are from previous. So let's go to see the size. So the size there, that's about 42 meg, roughly. And 42 meg is, you know, a larger file, so it does show that it's beyond just that model specification, which is relatively small. It's much larger. If I were to go to the model, now I'm going to do script. I'm going to script it out as an XMLA file. Now I'm going to do only the first one, which is the association analysis. So this is the first model in XMLA. XMLA is like an XML representation. Oh, I went off the screen. It's an XML representation of the mining model. And you can see there on line 3 it says Contoso Retail, the mining structure is basket analysis, and the ID for the mining model, it gives their online sales order. It shows the column names and some of the characteristics of the model. And it doesn't really show a lot. I mean, that's like 37 lines of a text file. Now, obviously, that specification, that itself represents the untrained model. That XML represents the untrained model. And when I did that export, it was 42 megabytes. So obviously, that's much larger than what it takes to specify the model. We can do another one. This is the clustering model. The clustering model, it's got a few more lines, goes to 84. But then obviously a lot smaller than that exported file that I created. Okay, so I exported it. So now what I'm going to do is I am going to switch to another database I made called TechEd 2011. Now if I go here and I try to open some of these files, there's nothing in there. I'm going to run an import. I have to change it in the upper left corner. So I'll show you I'm changing in the upper left corner. I'm going to change the database to TechEd. Import. Run that. So this is an example, reading and writing. So I wrote to a file, and I'm now reading from that file into a new database. I do a refresh, and if you look what happened, here's what it did. This was empty. It gave me the data source view, and it also gave me the mining structures. If I go to one of those mining structures on that new database and I open to browse them, I can take a look at what was in that structure. Again, that was the association analysis. Okay, so this shows about reading and writing. This shows about moving things around. This type of activity is very important in the enterprise environment, to be able to move sections or pieces. Or remember that 64,000 thing? All right, so if you do that 64,000 thing, just before I get there, this is what you want to do. Take some of your models out and put them in a few different databases so I don't have to beat you up. All right, so that's a way to move from one structure to another. Very common and important task. And you know, also what makes this an enterprise solution is that everything that comes with analysis services in terms of security, authentication, authorization, backups, all that infrastructure is true for analysis services. In terms of scaling up or scaling out, I recommend a website called SQLcat, SQLcat.com. It's a high-performance website, and you can look on there and see what some of their performance tips are for scaling up analysis services. And the key is, once it gets into analysis services, then the enterprise part about making the performance happen might have to do with either making a specific box bigger or adding servers together and putting them in some sort of farm. In addition to so that's import and export. I can also look at some of the test structure cases, the training cases. In any data mining project, not all the original data needs to be presented as training data. Some could be set aside as test data, and the purpose of the test data is to randomly check the training case and what that did. The bottom statements here have to do with clearing. And I find this a little bit tricky, that when you want to clear or empty out the training or the past processing, you use a command that says delete. Now that makes me nervous. Anytime I see the word delete, I don't even want to push it. But what it's deleting is it's deleting the training data. And they decided to use a different word when they mean completely erase that mining structure. They use the word drop. Okay, I'm just describing. I probably would have flipped the words if they were up to me to make this language. I would use drop for the other one and then delete to actually delete, but that's the way it is. All right. I'm going to go, so that's face number one. Face number two is bids. And if you look on the upper left corner here, we're in Visual Studio. In the current release of 2008 R2, this is implemented as an extension of Visual Studio 2008. So you do not need to have Visual Studio license. This comes with SQL Server. This is not something extra you have to buy another product. This comes with it. It doesn't provide all the features of Visual Studio. It just provides the ones related to managing SQL Server. I have four on the right side. I have four packages that I made in Integration Services, one called Creation, Delete, Transfer, and Processing. So I'm going to show you what they are. First I'm going to do the delete. Now what happened earlier, you remember I put structures into that new database called TechEd. Now if I went here on the left side here, you notice that there's a data source view. If I go in there and try to delete that, so I'm going to press delete. Now what it's going to do is it's going to give me an error. I'm trying to delete something and it's not letting me delete it. And the reason is because I click the error. Now the error might not be that clear. Errors in the metadata manager was invalidated. Cannot be committed because one or more objects were invalidated during the transaction. Okay, it's kind of the typical cryptic error. And the reason I could not delete it is because these elements are joined. There's a dependency for the mining structure and the data source in the data source view. So here's a sequence of things that have to happen. So let's look at the screen here, that have to happen before I delete the data source view. Each of those boxes represents a transaction. And in this case, I'm using scripting called DDL. That's the same type of scripting I've created with the XMLA. And those four things have to happen first before I delete the data source view and before I delete the data source. So I'm going to, and also I put this inside a framework, which I put a note in there what that framework is. I do recommend frameworks for integration services if you're going to run for production code. And I gave an example of one where the demo code is online, so you can go take a look at that. And what I'm doing right now is I'm running the interface. This is integration services. There's two ways to run, at least two ways to run integration services. One is just doing what I did. And as you notice, it went through and it made green boxes. Green means successful completion. This is an interactive way of running integration services. This tool is used for ETL, which is extract, transform, and load for data cleaning. In production environments, people often use this as scheduled jobs. So you could take this job, you could put it on a schedule, it could run early in the morning, doesn't have to run during the day, and then I press stop. So what that did is it cleaned out the structure. So if I go here and refresh, there's nothing there. Okay, so that's reading. We're doing reading and writing. Now, if I were to do, this is kind of the mirror. This is the opposite. Well, it's kind of the opposite. Well, let me talk through it. The first box here has to do with creating a data source and creating a data source view. And then on the bottom has to do with creating structure and models for those four models from Contoso Retail. But the difference here is that what it's creating is exactly what I showed on the other screen. Let me go back to the screen. What screen is he talking about? When I did Contoso Retail and I opened the mining structure and I made script a mining model, create to new query window, this amount of code is what it's executing. It's executing just a structure and no training. Structure with no training. Press run. And by the way, we are going to have time for questions. So if you have a question about data mining, just go ahead and think about whatever you want to ask about that, and I will be happy to answer that as we are getting close to the end. So these structures will be created now in the new warehouse. So I'm going to refresh. And you'll see mining structures there. But then if I try to open one, browse these new mining structures, it actually goes there, and then it gives me an error. And that's not a bad error. The reference model has not been processed. It's not been processed or not trained is the same thing, and then it gives me a blank screen. That's what it gives me. So I'm going to go back. Now there's two approaches from bids, because we're looking at bids now. One approach is I could process it. And this script shows that processing. It's done as one step, and on this computer in the current configuration, it takes about 8 minutes. So, too long for a demo, but this code does work. If I were to open the box here, and I'll show you what's inside, it's just a GUI here that's set to process those 4 mining structures. And it's a process full, so it's a complete refresh of the data. And you can just add more processing steps. By the way, this is a general analysis services processing box. You could do any type of processing added to this list. Process your cubes, whatever. Add other things. And that could also be scheduled as a job. That's good for enterprise. Why? Because you may have a lot of data. You might not want to be doing this during the day when you have large data sets. We have 8 minutes. What are people's time expectations? A lot of times now for search, people want to get results like in 1 second or less. And so in terms of having results ready for analysis and ready for an enterprise, it may take some sort of processing like this to do something overnight. I've even heard of, and you can look this up for yourself, of people entering competitions for data mining and using desktop computers and telling stories for letting processing run even for several days on certain types of problems. That was true in the recent Netflix competition, where people had different algorithms or models and they were running for some amount of time. So it's not necessarily, depends on the amount of data and also what processing is happening. It might take a while. It's always good in a production environment to have an interface like this. Basically, if you took out the window dressing, there's really only one box on this screen that does the processing. And someone can figure out how to do that. But I'm going to do a different path. I am going to do a path that's kind of similar to what I did in Management Studio. And that is, first file system task is going to check that the file is not there. It's going to export those structures into a file, and then it's going to import those structures into that new database. So let me check here. Do I refresh my screen? Remind myself. Okay, so there's still stuff there. And so I have to go to the delete first, and I'm going to delete what is in there. This is what Integration Services made was untrained models. Okay, now the transfer is going to take the original files from one analysis services database. It's going to make a file and then read that file into the new area. And one thing you have to be concerned about if you are going to do this type of structure is make sure that file is in a secure place, because the file itself does have information or data from your organization. So you would want to make this file in a location that meets your security requirements. Once that's done, I do a refresh. And this was done from Integration Services. Browse the model, and then there's my time series forecast. I now have a copy of it, and it's in actually two places. It's in that physical file I made, and then it's also in the Analysis Services database. It is true that you can also back up your database, so you could also back up the entire database. You see there on the left, and that will take everything that's in the database in the state that it's in, trained, untrained, processed, or whatever state it's in. And you can back that up to a file, which is how Contoso Retail is even shared in the first place. Okay, so that's integration services. Now let's go to PowerShell. I have had some sort of an affinity to PowerShell, and I think a lot of the reason, a lot of my professional experience has been working with the SaaS technology, and I've presented some SaaS conferences, including SaaS Global Forum. There is a SaaS technology called SaaS Macro, which is not important for me to describe in detail, but it does similar types of code generation. And even in the Unix world, Unix-Linux world, there's been scripting programs that have been available for many years, like decades. Well, now I feel Microsoft with PowerShell version 2 has played catch up and has developed really a way to access the entire .NET framework from either this integrated scripting environment, which is what I have open. This is just a scripting environment where you can open a script and write like a mini program. Or you can use a window, and I'll just show you the window since I have time. I'm going to open it as administrator. Now you can do dir or anything that you would normally do, but you also can make aliases. So you can do ls and it will list files. I could do cd to the environment. Now what I'm looking at is on there, it's treating the environment variables as a drive. And I'm listing now what the environment variables are on this computer. Now that was important for this project because the framework that I'm using in integration services requires an environment variable to be set to show where the configuration file is for the project. And in this case here, if you see on line 8 and 9, I'm making string variables. On line 10, I'm getting the username, and I'm using that username as the dropped-in variable for a package that would be put on a user's desktop. So this one would automatically figure out who you are as a user, put that name in there, and then it will set, line 12, it will set the environment variable to a specific value. PowerShell does many things. So there's often a way to find a solution, and if you ever wanted to get some quick technical support for PowerShell, send your question to Twitter and put the hashtag POSH. So if you put hashtag POSH and you send your question to Twitter, you will get an answer very quickly from the PowerShell community that monitors that. Now, one thing I had done on my blog, I had done a review of a data mining book that I recommend. It's called Data Mining with SQL Server 2008. It was written by the Microsoft team that developed this technology. In one chapter, they had some code that had to do with programming AMO, which is Analysis Management Objects, and ADOMD.NET. And they implemented it as C# in the book. They gave the code. They showed what it did. You know, it's not super spectacular complicated. They just showed how to accomplish some basic tasks. I took that code and I translated that console code into PowerShell. And I showed how to do that on the blog. And what's been interesting on my blog, I had a surprise. My surprise is, and as looking for, because I'm using WordPress, looking from the search engine queries, people are interested in writing PowerShell with either AMO or ADOMD.NET. And my examples are some of the few examples which are out there for those classes. And I'm mentioning this, if you're a developer and you're interested in blogging or you're interested in adding to the community, there's a lot of PowerShell examples that have not been written just because nobody has put examples out there. And this is just one I happened to hit. So this example I have, this is going to do a very simple thing. And the code here, as you see on line 84, it's going to check if a specific directory exists. If it doesn't exist, it's going to make it. And then it's going to remove that file if it does exist. Then it's going to try to do that export mining structure. This is the DMX code that I showed earlier in Management Studio. It's opening a connection with ADOMD. As you see on line 94, ADOMD is the technology. And then in line 106, it's it starts the section for importing that back into the original memory space. Now, one thing I have to do before I do that is I have to delete it because it's already there. So first I'll delete it. And then I'll go, in fact, I'll show you another, no, let's just go forward. Let's move forward. I'm going to run that. There are 3 windows. One, the top window is for code. The bottom window is interactive, so you could type in commands there. And then the middle window is kind of a results window. So if I run it, you see things in the results window. It's transferring the model. Again, this process took about, I don't know, we saw it already 2 times, maybe about 20 seconds. And once that information is done, it will go to this directory. Now, on the left side, it said finish your transfer process. That's just a nice write to host command that I made. And then it made that third file, which is in the middle, PowerShell.dmb, and 42 meg. I want to say something about DMB as an extension. You can make any extension you want. Doesn't matter what it is. And I've seen 2 different explanations in books online. This is a trivia question. The normal extension for analysis services backup database, does anyone know what it is? Sorry? BAK is for rate relational. So the one for analysis services used is ABF. You will see in the documentation, they will say use ABF. And then sometimes they will say DMB. And the technical explanation is this DMB is not considered a full ABF for some reason. Now, functionally, it doesn't matter what you name it. You can name it whatever you want because then you're just going to read it back into the program and it will recognize it. So the actual name of the extension doesn't matter. I prefer using DMB because it's the one that I've seen more often used for data mining. So I'm just explaining why I'm using it, but there's really no technical reason for doing it. You could name it the extension whatever you want. Doesn't matter. All right, let's go back to the slide deck. So that's the demo. I'm going to go back to the slide deck, and then we're getting close to some opportunity for questions. So these links here give more information on the structures and the models. I find that the links always look intimidating, but when you actually look at them, the explanations are actually very clear about what is a structure and what is a model. In terms of next steps, as I always say, you can get all this software at least on a trial basis. And in fact, I'm going to give you a way to get it free, but let me talk about the trial basis first. SQL Server R2 Enterprise you can get for a trial basis, and there's also a developer edition, which is much less expensive, and that will only work on one machine. And the second thing is Microsoft Office 2000 Professional. We did not talk today about the Excel data mining add-in. I have some videos on my website, and you can see them for the Excel add-in. That's free, but it only works with either 2007 or 2010. And that's often a good way to get into the technology. The third one's PowerShell. PowerShell comes different from the SQL Server, and it's something you could use anyway. It does not require SQL Server. It's something I do recommend for enterprise environments or enterprise management. It allows full access to .NET. It completely replaces command prompt, period. You do not need to use command prompt anymore, and if you do, you can actually call command prompt from PowerShell anyway, so what's the difference? And then my data mining portal and blog. And what I've tried to do on my data mining portal is pull together information that's not in other places. So if it's not somewhere else, I will put it there on my blog. All right, back to our ships. Now, you might feel like this. This might be you and the next day going to work and having to deal with rapids and turbulent times and changes. Some people resonate with this picture. You might feel like you are stranded. But my premise today with using these tools, these enterprise tools, is that you can experience smooth sailing if you use these enterprise tools. So my conclusion, so data mining leaders can tackle enterprise data mining challenges. And you know, if you're in the enterprise environment, I consider people in this audience leaders of leaders of leaders, because you have an impact. You might not have people that report to you, but you do have many people that might rely on the data or on the systems that you build. And that's what makes an enterprise environment. SQL Server Management Studio, Business Intelligence Development Studio, first two products come with SQL Server. The third tool is a Microsoft freebie, PowerShell version 2, and it enables you to become more effective leaders of leaders of leaders. More information there, the data mining blog, SQL Server data mining, and Microsoft's TechNet. And by using all this information, you can become an effective data miner. I like to use the helmet too because, you know, this shows that you do need to be careful. You can get hurt. And also when you do data mining, you can also cause a lot of damage. Often data mining, you know, will be heard about in the news, about all the damage and all the things that people can do. So you know it can be very dangerous. So just know that you have a lot of power when you take a lot of information and you're making your extract, you're making that compression of information. That could be very dangerous. So that's a theme that I like to bring up of knowing that these tools are very powerful, especially done on the enterprise level. Now, I do have some time for questions. If anybody has some questions, maybe step up to the microphone, or if not, I'll just repeat it on my microphone.
I actually have a couple of questions.
Sure.
Typically, my experience with design data mining applications, the results and what you mine is very dependent on how you fine-tune your data mining algorithm.
Uh-huh.
Now, what I saw from the tool itself, so basically your supervised learning algorithm, you're doing clustering,
Uh-huh.
and then you're doing the supervised learning. Now, how would you address situations where, say, you might want to reduce your feature vector, or like when you change the cluster
Right.
far, maybe that's the k-means. Now, how do you address those issues? Because it looks like it's a very general set of tools that you're using to gain some kind of.
Right. So the question is about model creation. And I did say at the beginning we aren't going to talk about the arithmetic or making the model, but I will give you a resource. First of all, on my blog, I do talk about making models. I often do that with Excel because I think using Excel or using just a subset or a sample of data gives people a feel for how the algorithms work, even before you go against a larger data set. Someone walked up to me during this conference, and they work for Microsoft in one of the Microsoft marketing areas, and they said they had a 3 billion row data set. And they were asking the question about how to approach that. Should they take the whole thing? Should they take a sample? We talked about some of the advantages and disadvantages both ways. Obviously, if you do 3 billion, it's going to take a longer processing than if you did a sample or subsample or subset. Maybe you want to break it up into different subsets. There's different ways to break it up. A lot of it's driven, I don't think, by the mathematics. And this is where I vary maybe with some people who write on this topic. For machine learning purposes, it's really about the business question. So when I work with my clients, I will talk to them interactively about what types of questions are you looking to answer. And it's an iterative process because sometimes you have to allow people to go back and forth. The reason, too, I like Excel, as I like Power Pivot, as I like a lot of the self-managed BI tools, is it gives people who have content knowledge the ability to look at the results because their observations are just as critical, or even in many cases more critical, at least in my experience, than fine-tuning the parameters or even than picking the variables. They may have even more insight into how to categorize the information. So let me see if someone else has a question and I'll come back to you. Does anyone else have a general question about data mining or anything? Okay, so I'll let you go.
The other question I had, data.
Mhm.
Now, let's say your training data has to be, I don't know, 100,000 rows. Now, a human has to go in and label that training.
Correct.
Who does that?
Right. So the question had to do with labeling data. Who would label the data? There's several ways to approach that. One would be to label the data as it's processed through the ETL before the model's built. And that could be done, for example, in integration services. And let me give you an example. Many data warehouses have columns of codes, and they're just numbers, 1, 2, 3, 4, 20, 25. But they're not friendly. They're not in words that people know or understand. So a way to approach that would be to make a new column with the codes and relabel that using a tool like integration services before presenting it to the data mining tool. And then what will happen is when it gets trained, and then as we saw today, because see, this is why the reading and the writing are important. So actually your question shows some insight as a result of this presentation, because you realize that those labels will now be stored as part of the trained model inside analysis services. So you want to make sure it happens before the model is built.
That, and also my concern or question is, how do you get around to such a big task of having people label
Right.
it? In the end, if you have to create training data,
Correct.
you have to have people.
You do have to have people programming it. So it does have to be programmed, and it does have to be processed through an ETL system. And that is where some people say that data mining requires 70% of the time to be spent on ETL tasks. The task that you just listed is one of those tasks. And it's a recurring task in the sense that it does not go away even in the future, because you will still need to track what those codes mean in some sort of table or some sort of source system. Microsoft has a new technology called Master Data Services that help people track such things like dimensions like that. And that's used to be able to create maybe historical looks, like codes may change over time. I've been in organizations where some codes change every year, and they have a different lookup table for every year. So Master Data Services is a tool that helps people manage that type of dimension or attribute values changing over time. And it does represent something that people do have to consider. So to answer your question, yes, it's not just a matter of reprocessing a model necessarily over time. But if you knew that those codes were coming from the same place, then yes, it would not require recoding or anything like that. Or even in the case that I gave you about the date. Date could be one of the variables that could be introduced somewhere out of a query, stored in an integration services variable, and then used to make a decision about what type of cleaning or processing would happen. So that's something that could happen dynamically as part of the ETL process. But yes, someone does have to look at how these models are built and pay attention, right? Yeah. Okay. Well, anyway, thank you all for coming. And anyone want to come up and take one of my cards or ask any other questions? I appreciate that. Appreciate your attendance.